Okay, let's go. Let's go. All right. So chapter 28, chapter 28, we now go to 65. All right. We now go to 65. Okay, 65 is even where I was. 65. All right. Yes, so this is 65. The device says the primary coil of a transformer has n turns. N turns. So meaning we are looking for the primary turn. Just know that already. N turn and is connected to a 120-volt AC power line. If the secondary coil has 1000 turns and the terminal voltage of 120 volts, what is the value? All right, so 65, always remember, we start from what we were given. So that is primary voltage. Primary voltage is 120. Um, secondary voltage is 1200. Secondary turn, secondary turn is 1000. Primary turn is what we are looking for. All right. So we are looking for primary turn. That's what we are looking for. Okay. So formula to look for. Normally, the normal formula is secondary turn over um, primary voltage is equals to. Sorry. So sorry. This is um this is voltage. Yeah. Secondary voltage over primary voltage over secondary turn over primary turn. Yes, that's the formula. But now we're looking for primary turn. So primary turn will be NP, that's primary turn, is equal to secondary turn primary voltage over secondary voltage. All right, plug in your numbers and solve. Good luck. Next number should be 72. Let's go straight there. 72. 72 says a circuit has an area of 0.4 meters, that should be square, and consists of 50 loops of wire. If the loops are twisted and allowed to rotate at a constant regular velocity of 10 rads in a uniform magnetic field of 0.4 T, that's 0.4 ton, the amplitude of the induced voltage is the amplitude of the induced voltage. So we are looking for the EMF maximum, the maximum EMF, and then that's for 72. 72 to find EMF, that's the max. We'll just do N times B times A times W. All right. So that's what we're doing. N times B times A times W. What is N? N is 50. What is B? E is 0.4 ton. That's T. Oh, yeah, just leave it like that. 0.4. What is area? That's A. Area is 0.4 also. And what is your W? Angular velocity, that's your 10 rads. All right, so plug this into the formula, and you're good to go. All right. Okay, so we go to number 77. Number 77 says a proton moving with a speed of 1.0 times 106, oh sorry, 1.0 times 10 to the power 6 Yes, that's 10 raised to the power 6. Yeah, that's the speed. Through a magnetic field of 1.0 T, 0 T, express the magnetic force of magnitude 8.0 times 10 raised to the power minus 14. The angle between the protein velocity and the field is what? So we are looking for the sine theta, that's the angle. So they gave us protein charge as 1.6 times 10 raised to the power of 19. That's what they gave us protein charges. All right. So this is 77. The formula is what? Sine theta. Sine theta is equals to, okay, we've not gotten there. Let's write this general formula first. Let's write the general formula first so that we'll take it from origin. All right. Let's take the general formula first. Okay. So the general formula is F is equal to Q U B B sine theta. All right. So now we're looking for sine theta, right? So make sine theta the formula. If you make sine theta the formula, it will now be sine theta is equals to F over Q U B. All right. So let's take down things that we have. Okay. So what we're given is one protein speed, which is this small v here. So protein speed is equals to what? 1.0 times 10 raised to power minus, oh, sorry, 10 to the power 6, that's protein speed. Then we have your B. Your B is 1.0 T. Then we have your magnetic field, which is F. That's your F now. Magnetic field is 8.0 times 10 raised to the power minus 14. Okay. Then we have your Q, which is your charge. Your Q is charge, which is protein charge, 0.6 times 10 raised to the power minus what? 19. So plug all this into this. Any answer you get, then you find the inverse of that answer, inverse sign of that answer. So any answer you get from here, what you now substitute to will now be theta is equals to sine inverse of that number. Let's say the number is n, of that number, you get your answer. All right, let's go.